This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at this interesting paper from Microsoft Research. So it talks about a multimodal large language model called as Kosmos-1. So Kosmos-1 can perceive both language and images. It can learn in context, reason and generate. So what does this mean? Okay. So if you have a picture like this, right, and you have a text, what is in this picture? If this is given as an input to this multimodal large language model, then it says it looks like a duck. So it is able to perceive the image as well as text. And then you can have conversations in text like this. That's not a duck. What is it? Okay. So this is what this model does. Another example is given over here. So given a description of two types of woodpeckers and an image of an woodpecker, you can then ask a question, what is the name of the woodpecker in this picture? And then it answers that. Okay. Another example is present over here where there are a set of images and the text. And then you are asking the following image is. So what follows this particular set of images? Right? And then the model tries to answer it. Okay. So it is capable of perceiving multimodal input following instructions, and it performs in-context learning for not only language tasks but also multimodal tasks. Okay. So this is Kosmos-1. Here are some more examples of this particular model. So here you have something like this image is present and there is a question, why did the little boy cry? And it gives the answer as, the model completes it as, because his scooter broke. So this is an example of visual explanation. Then you have visual question answering over here. Question, when will this movie be released? Again, there is a poster of Wall-E. So this Wall-E poster plus this text is input. It answers this. Okay. This is actually answering from web pages. So there is a web page present over here, and then the question is, what is torch scale? An image of an web page, an image of a mathematical equation. Okay, this is from the image. It is trying to answer what is the heart rate in this picture, and it gives 57 beats per minute. What is the time in the clock? 10:10 on the large clock. Okay, so it is capable of doing these things, and these are selected examples which they have presented over here. So now let us look at, this is some more examples of the same thing. This is image captioning. This is question answering. Okay, what coffee shop is in the background, and it says Starbucks. Run this Starbucks over here, right? Then there are some, basically this is like OCR-free processing, right? So an image is given, and then it, identifies what is there in the image without doing OCR. Okay, so that is what they claim. Right, and this is visual dialogues over here. What is this picture? And then you kind of have a visual question, like it's a dialogue, chatbot basically. So this model is capable of multiple tasks like language understanding generation, OCR-free NLP, right? Directly fed with document images basically, perception language tasks including multimodal dialogue, image captioning, visual questioning, answering, vision tasks such as image recognition with descriptions. Okay. So now let us go into what is this particular model. Okay. So what is this model large language model? Okay. So what is it? So it is actually a transformer based causal language model. That is the backbone. Okay. The other than text, other modalities are embedded and fed into the language model. So the transformer decoder serves as a general purpose interface to multimodal input. So they train this particular Cosmos on multimodal corpora, including monomodal data, text data, cross-modal paired data, and interleaved multimodal data. Okay, monomodal could be either image or text. Cross-modal paired will be image and text. Interleaved is image plus text, right? Once the models are trained, then they can evaluate this particular model in zero shot and few shot settings. Okay. So how is the input representation over here? Input is represented as a flattened sequence decorated with special tokens. So S and /S to denote start and end of sequence. The special tokens image and /image indicate the beginning and end of encoded image embeddings. document, paragraph, and this thing is document is a text input. This S paragraph image embedding, again paragraph is interleaved image input. Okay, so there are some examples over here. So these are the examples of, say, image caption, right? For image caption, it is an image embedding. Then there is this text. Okay. For multimodal, see here, you have image embedding, text, again an image embedding. Okay. So this is the input format. An example is shown over here. So how they conduct zero shot and few shot evaluations. For example, image embedding goes an image of, okay, and Wally giving potted plant to. So this is interleaved and it is trying to predict Eve over here. So Wally gives to Eve in this particular image, right? Another example is this where, the first part is Wally gave the, what did Wally give Eve? Potted plant is this thing, and what is there in Wally's hand? So that is the Rubik's Cube. So this is few shot learning for, how they evaluated this particular model. Okay. Now let's go back to our model part. Where is it? Should be here. Okay. So this was about the input representation, right? And then you have about, the training objective. So the training objective is next token prediction task, learning to generate the next token depending on the previous context. Okay, because they can, embed images plus text, and they can also have interleaved data. The output is always text. So that is what they are trying to, basically predict over here. So this talks about dataset, but we'll go to the training setup. So this particular model has 24 layers with 2048 hidden dimensions, 8192 the feed forward network intermediate size, and 32 attention heads. It is a 1.3 billion parameter model. Okay. So they use a particular transformer called as Magneto as the backbone. So Magneto is explained in, it's a foundation transformer from Microsoft, and it is explained in this paper. I'll be putting the link of this paper in the description of the video, right? And what they do over here is that for the image representation, they are using a pre-trained clip VIT model with 1024 feature dimensions. The images are processed into 224 cross 224 resolution during training. They freeze the parameters of the clip model except for last layer during training. Therefore, the total number of parameters of this model is just 1.6 billion parameters. Okay, so for a 1.6 billion multi-modal language model, it is actually giving very good results. Okay, so this was about the model, right? Then here they talk about the various text corpora and image caption pairs, interleaved image. What is the data sets? I will not go into the details of that. You can read through the paper for that. Now, what did they evaluate this particular model on? They evaluated this model on language tasks for language understanding, language generation, OCR-free text classification, for cross-modal transfer, which is common sense reasoning, non-verbal reasoning. We'll look into each of this as we go ahead. Image captioning, visual question answering, web page question answering, vision tasks. Okay. So let's look at some of the examples. So this is for image captioning, and they claim that this particular model has very good results compared to other models over here, right? So examples we have seen before, right? Given an image, it has to generate a caption. Okay, this is zero shot. This is few shot results. This is visual question answering. Okay. Again, the results of visual question answering is presented over here. So this is few shot visual question answering. This is the special this thing over here which talks about an IQ test. Okay, so given a image like this, a matrix of images like this, and a question, which option can complete the matrix, and then you have these answers over here. The model should predict what is the right answer over here. So how do they do it? What they do is that they give this particular image as an input along with text, along with this image as one result, as one input. Another input is this particular matrix, this question, the second input, and they take the probability of each of the outputs and see which gives the highest probability. That is how they do it. Okay, so that is what they explain over here. Here are the images, all the images, right? And then one by one, is it correct? Is this image correct? Is this image correct? Is this image correct? So they send it, say 1, 2, 3, 4, 5 times over here. Okay, 6 times basically, 3 plus 3, 6, right? 6 times they send it, and whichever gives the highest probability, they say that is the answer over here. So that is the Raven IQ text. This is for non-verbal reasoning. Okay, so it is a reflection of an individual's intelligence quotient. So given 8 images represented in this 3 by 3, the task is to identify the following element from 6 similar candidates. So here, when they evaluated, they say that if you do random choice, the accuracy is 17%, this model is 22%, and with language only instruction tuning, it is giving 26%. So they say that compared to humans, this is really behind, but then compared to models, other models, this is much better result. Okay. So that is what is this particular Raven IQ test. This is quite interesting, even though the performance is 26%. Okay. Then you have this OCR-free language understanding. So basically, if you have an image, okay, so the sentiment statement sentences are converted and rendered as images. Then there are also hateful memes in another data set. They prompt the model saying, question, what is the sentiment of the opinion? And they pass the image plus this text, and the model is expected to answer positive or negative for the sentiment. Similarly, for the hateful memes, yes or no. And this is the kind of result this particular model obtains compared to other models like Clip and Flamingo. Okay, this is without OCR. Okay, web page answering, as I explained before, a web page is present, image of a web page, and basically no. Text extracted from the web page as input, not an image. Sorry about that. So text extracted from the web page as input, and given the context below from the web page, extract the answer. Okay, who is the publisher of this book? That is what is the example over here. And this also, it gives good results compared to just a large language model, which they have trained on the same text. Okay. Then you have multimodal chain of thought prompting. I had covered that in a previous paper. The idea over here is that given an input image, if the model is able to generate a rational and then it tries to answer, it gives better performance. So that is what they do over here in multimodal chain of thought prompting. So given an input, it tries to answer, it tries to generate a rational around the input, right? Then given these two as inputs to the model, it is able to give the answer properly. Okay. So here they have compared the results again with Clip and they say that it is other models and they say it gives better results. Okay. The next category is actually some kind of, identifying visual categories given text descriptions. So in this case, you have description of a particular woodpecker, description of 2 types of this woodpecker basically, and there is an image of 1 type over here. And given this question, it is able to identify the category. Okay. So that is this particular image classification with descriptions. Okay, here are more examples of, you have very good descriptions of say Gentoo penguin and royal penguin, and given an image of either one, it tries to identify it. That is the image classification thing. Okay, and here are the results. And then they talk about purely language tasks over here, the various benchmarks. I'll not go into this. Okay, and how this particular model is much better than say large language models in certain benchmark, and in certain cases this is better. Okay, so then you have cross model transferability. That is like if it is only trained on text, how does it perform on image? And if it is just trained on image, and how does it perform on text? That is what is explained over here. So then they talk about visual common sense reasoning task, that is understanding the properties of everyday objects. So here it needs to, language models needs to understand more information from the object properties. Okay. So here they have given some results on that. Okay. So these were some of the tasks and how this model performed on these tasks. And if you look at the appendix, they have given examples of what are the hyperparameters of this particular model. Right, and then the data sets over here, what data sets it was trained on, some evaluation, how did they do the evaluation, right? So that is what is explained over here. So this is quite an interesting development that a 1.6 billion parameter multimodal large language model is capable of doing different tasks like this. I hope this model and the code for this model is released, because then we can really try it out, because currently all we are seeing is selected examples the model may not perform as well as we expect when we give our inputs. So I will share this particular paper in the description of the video. I hope this video is useful for you. If you like the video, please like, share, subscribe to the channel. See you in another video.